Welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at question 5. We're given the word excellent, and we're asked that if the repeated letters are considered different, then how many ways can we arrange the letters of the word? And we can assume that any combination of letters is a valid word. Okay, so first of all, let's break up the word excellent. I count 3 E's, 1 X, 1 C, 2 L's, 1 N, and 1 T. So altogether there are 4, 5, 6, 7, 8, 9 letters in that word excellent. Okay, so there will be 9 factorial ways, but we don't divide out any repetitions because we assume that the repetitions are considered different, not identical. So our solution here would essentially just be 9 factorial ways to arrange those possible letters. So we get 9 factorial equals 362,880 ways. Next, we consider the repeated letters to be identical. So now we have 9 factorial, so 9 letters, but now we divide out the repetitions. So there were 3 E's, so 3 factorial, times the 2 L's that were repeated, times 2 factorial. Okay, so let's go ahead and do that on our calculator. So we're dividing that answer by 3 factorial times 2 factorial. So there are restrictions now. The repeated letters are identical, so we're removing them. So we should expect a smaller number, and we do. 30,240 ways that we can arrange the letters such that the identical letters are considered the same, or the repeated letters are considered identical. If the first and last letters are identical, okay, so now again, we're not saying that the repeated letters are unique anymore. So we can assume the repeated letters are identical. So again, remember there are 3 E's, 1 X, 1 C, 2 L's, 1 N, and 1 T. So let's consider the possibilities. 5, 6, 7, 8, 9. We could have, of those 3 E's, we could just have 2 E's repeated. Okay, it could be any of the any of the 3 E's, just 2 of them. Put them in the first and last letters, so they're identical. So how many letters left over? There are 7 factorial letters left over, okay, because we've used 2. However, there's a repetition of 2 L's here, so we need to divide out that repetition of those 2 L's. So in the first possibility we have, where the 2 E's of the first and last letters are identical, therefore we have 7 factorial divided by 2 factorial. The second option of those same 9 letters is that we could have the 2 L's as the first and last letter. And again, we'll have 7 factorial letters left over to arrange. However, there are 3 E's that are still identical that need to be divided out by the fundamental counting principle. So we have option 1 or option 2. And in counting methods and in probability in general, when we have or, we are adding those possibilities. So it's 7 factorial over 2 factorial plus 7 factorial over 3 factorial. So if we do that on our calculator, let's see what we get. Okay, so it's going to be 7 factorial divided by 2 factorial, which is just 2, and then 7 factorial over 3 factorial. And I get an answer of 3,360, even smaller number than the previous one, because now there was an additional layer of restrictions, first and last letters. How many arrangements can be made if the word must end with a T? So again, there are 9 possibilities. Okay, 4, 5, 6, 7, 8, 9. But the last letter must be a T. That's a given. So therefore, there's only 8 letters to work with, 8 factorial. However, we still have repetition of 3 E's and 2 L's. So therefore, our answer now by the fundamental counting principle is 8 factorial. Okay, the 8 letters remaining divided by 3 factorial times 2 factorial. That's equal to 3,360. All right, so remember this one way here is just counted as one option. So we could say that times 1, but that still gives you the same answer. Okay, interesting that these last 2 worked out to be the same number. And then lastly, how many arrangements can be made if the word must start with an L? Okay, so there again, 4, 5, 6, 7, 8, 9 letters. This first one must be an L. That's given. So there's only one way that could happen. Okay, not 2 ways because there are 2 L's, but those L's are identical. So we just say that there's just one way of counting it. Okay, but now again, we have 8 letters to arrange. However, now there are 3 factorial ways of arranging the e's, okay? And that 1L is now gone, okay? Because it's already counted here. All right, so 8 factorial divided by 3 factorial. Let's go ahead and check what that is. So we have shift 8. Let's go back. 8 factorial divided by 3 factorial, and we get 6,720 ways. All right, so that's how we would do this type of question. I'll see you in the next one.